In this video, I'll be introducing the universal and existential quantifiers, but first I have to introduce the propositional function. The propositional function, denoted p of x, takes on a value of true or false, but it takes on a value of true or false for everything that you feed to it. So in this case, with the universal quantifier, this is read as for every, you would say for every x that is an element of the universe, p of x is either true or false for every x. The shorthand for this is for every x, p of x. You could also say there exists, that's the existential quantifier. There exists is just stating that there is at least one. So if we say there exists an x that is an element of the universe, we're saying there is at least one x that is an element of the universe, such that p of x is true or false. And you can again use the shorthand, there exists an x, p of x. So when we look at these examples, for every x that is an element of the naturals, x plus 3 is greater than 4. So that is a false statement because the first value of the natural numbers is 1. So x plus 3 is 4, which is not greater than 4. Also, for every x is an element of the real numbers, x plus 3 is greater than 4. That is also false. I can think of, well, there are infinitely many numbers that are not true for this. And then in this case, I said there does not exist an x that is an element of the naturals such that x plus 3 is greater than 4. And that is also a false statement because if I let x equal 2, that 2 is a natural number and 2 plus 3 is greater than 4. So this is a false statement. There exists an element of the real numbers such that x plus 3 is greater than 4. That is a true statement because any number greater than 1 is going to yield a true statement in this case.